before we get started, a lot of this notes and stuff will come from the same world's finest physics that made the PowerPoints. So hopefully they line up pretty well. All right, let's get through this. Read through all of this. I'm not going to go through reading it for you because I think you've got that. All right. Some solutions here. Basic equation for density. Here we go. Rho equals m over v. Whenever you write equations, I find it is sometimes useful to say exactly what the thing is and maybe point to it. Volume measured in cubic meters. And then density. And our units for density will be kilogram over cubic meters. Which density is your class concerned with? That depends. For AP Physics 1, we're talking about volumetric. AP Physics C, we have volumetric, we have areal. I don't need to use V's and all of that. We have Greek letters. We have volumetric density, we have areal density, and we have linear mass density. And then for Physics C, electricity, and magnetism, you have those three, and then you also have other definitions for volumetric, areal, and linear mass, and that is relating charge per unit area, or charge per unit volume, or charge per unit length. Briefly explain how to measure the density of an irregular shaped object. This is the story you have come to know, where Archimedes had to determine if the king's crown was made out of real gold, and stuck it in a bathtub full of water. So that's what you want to do. You want to take an irregularly shaped object, stick it in some water, and if the water is right here, and we'll say that's the 100 milliliter mark, and then we put our object in there. Let's take our object out, and we'll put our object in over here. That's the 100 milliliter mark. When we have the object in, our water rises all the way up here to 120 milliliters. So that tells me that my volume is 20 milliliters, because this change in volume equals the volume of my object. If I can measure the mass of the object, then I can figure out the density using mass, which I measure using a scale, divided by volume to get that change in water depth. On the molecular level, why do denser fluids sink below less dense fluids? Okay, so let's say we have this pile of water here, and then we have this pile of oil over here. Surely from elementary school, we remember that water is going to be more dense than oil. You stack them on top of each other. And that is because water has more molecules closer together. And because there's more molecules closer together, that means there is this weight that each of those molecules collectively will have. This gets into the talking of forces and stuff, which we haven't done yet, obviously, but you know what forces are, push or pull. There's this weight force that keeps us on the ground, and that is the Earth pulling down on us towards the Earth's center. Well, each of these molecules, the closer they are together, the more there's going to be a pulling towards the center of the Earth. Meanwhile, with the oil, if it's less dense, you don't have as many collective particles there to have this same downward pull. So what ends up happening is the thing with the more downward pull is going to sink to the bottom. In this case, the water will, and the oil doesn't rise, it just doesn't sink. Explain how the density of an object determines whether it will sink or... I think I just did that, yeah? I guess we can... If the density of the object is greater than the density of the fluid, sinks. If the density of the object is less than the density of the fluid, floats. If an object is made of pieces of different substances, like a person made of flesh and bone, both have different densities, then how can an average density be defined? What do you think the equation for average density is? Average density is going to be your total mass. So you take the mass of the bone and the mass of the flesh and the mass of the blood and all of that, divided by the total volume. What that would look like is if we have this flesh, bone, and blood, let's say, we would have the mass of the flesh plus the mass of the bone plus the mass of the blood divided by the volume, the total volume, sorry. So the whole thing, all of the constituent parts. Remember that density equals mass over volume. So if I multiply each side by volume, then that tells me mass equals density times volume. I could make this substitution up here. So I could say the density of the flesh times whatever volume of the flesh I have, plus the density, put that in parentheses, keep those two together, the density of my bone times the volume of my bone, plus the density of my blood times the volume of blood divided by my total volume. That funny looking letter there, that is my attempt at a Greek letter, capital sigma, meaning sum of, adding up all